Hello everyone. My name is Lizan. I work at Google. Um, here's, yeah. I work on a couple projects. Beginning, I worked on extensible service proxy for Google Cloud endpoints, and then I worked on the project Istio, mainly focused on the security side, and I'm also an envoy maintainer. Um, uh, all my information pretty much is here. I speak Japanese as well, so if you have any question after this session, you can feel free to grab me and ask anything about those projects and anything to me. So today I'm going to talk about Istio weaving a secure service mesh. How many of you guys heard, attended Envoy talk this morning? How many? Okay, 80%, 90%. Um, how many of you guys heard about service mesh? I think it's in addition to that, since Matt mentioned service mesh. How many of you guys heard about Istio? Okay, cool. So here is today's agenda. I'm going to cover the service mesh concept, overview of Istio, what's new in 1.0, and also go to the security deep dive. Then I'm going to do a live demo. Hopefully it will go well. I'm really, yeah, okay, so. So first of all, how many of you guys are developing in microservices? How many? Half? No, sir, no, 40%. So let's talk a little bit about why we actually need a service mesh. So everyone knows the microservices recent trend. That is awesome that when your monoliths become more problematic if we need to scale certain capabilities within that code base, and you want to deploy services independently to scale a subset of your service. So you can pick any language that's more applicable to your particular business logic. So for example, you might want to use Ruby to write the front end, use Python to do machine learning tasks. So you can deploy them each other. So what happens when you start really scale the microservices? You deploy multiple regions. You actually have very large number of microservices. You go from maybe 5, 10, then 100 microservices. At that point, it becomes very difficult to understand what's going on. So it's hard to determine exactly which microservice is causing the problem when you have an issue outage of your service. Another thing, if you write this microservice in different languages, in each implementation of a given protocol might be slightly different, and you got different developers writing them each other, so you get different metrics and different logging. It's not uniform. So microservice might not that cool, and people are aware of that. So how do we resolve this problem? The answer is we develop a tool, which is Istio. So Istio is kicked by Google, IBM, and Lyft. We got huge interaction from the community. It provides a lot of capabilities. It's effectively an open service platform that allows you to manage the service interaction. The other key things here is it actually works across both containerized environment and as well as a VM-based workload, and it could potentially be on-premise as well as on cloud or multi-hybrid cloud. So it basically separates the application from the infrastructure, lets your application to focus more on your application business logic, and let the infrastructure to handle the network, call, retry, monitoring, logging stuff. So it also decouples the operation from the developers, just like the microservice does, decoupling your service to your application to different services. So Istio can run everywhere. We have extensible adapter mechanism for each Istio component. We support environment other than Kubernetes, but currently we still develop on Kubernetes first. There's another support like for Consul, Eureka, other, and the Cloud Foundry support as well. So there are three main tenets that the Istio provides from a value perspective. The first one is providing uniform observability. With Istio, you can effectively get a common set of metrics that are automatically implemented across the environment without actually having to do that from a developer perspective. When you deploy it, you automatically get that. You also get the operational agility, the ability to change based on an level 7 layer protocol context how you want to traffic to traverse through the mesh and what you actually want to do with that. And the last one is the security, which I'm going to do a really deep dive in later of this session. A policy will give you a very powerful tool to allow you to protect potential attacks from both insider and outsider. So let's talk a bit more about observability. So it's like transparently collect the common set of the observability from your services by Istio will putting a sidecar proxy in front of every service that you run. And that will generate the logging and monitoring metrics. And you also got the control that scales by directing traffic to multiple versions, like you want to do canary deploy, you want to shift your traffic to old versions to new version and roll back them. Security is really important as well. When you start deploy with one command, you can secure all your services by default. If you start deploy with Istio installed in your Kubernetes cluster, every traffic can be secured by default, and you also get a strong identity based on that, and you can perform the authorization check on that as well. So let's talk more closely into the architecture itself. So in architecture, I think this is pretty common, and some of you, if you heard about Istio, might already see this diagram before. The three components of the control plane, which is pilot, mixer, and citadel, and we put a proxy in front of each services, which is Istio customized envoy proxy. Sidecar will handle the ingress and egress traffic between services to the cluster and also to external service from external service. The proxy from a secure microservice mesh providing a rich set of functions with the L7 routing, circuit breaker, policy enforcement, and telemetry and recording functions. So pilot gives the ability to basically push not only the routing rules, and it also pushes the security policy and for the proxies. In this way, this example, we really used envoy proxies heavily. This gives you the ability to do A/B testing or like canary rollout, all based on the level 7 layer, which is HTTP or like gRPC. So Mixer is it's a pluggable control plane. The main two parts is the policy check and the telemetry collections. Every request goes through to proxy, logically go to Mixer to perform the policy check, and also the telemetry go to Mixer. I'm saying this logically because the proxy will heavily caches and aggregating the telemetry. So it not actually every request literally go to Mixer. This will save the Mixer from being a single point of failure. So here is I will describe a little bit more about life of a request. First, when you deploy Istio control plane components, it will push the configuration from pilot, and also Citadel will provide key and certificate to the proxy if you choose to enable TLS. So here, when your service A tries to call service B, the proxy in front of service A will intercept the call. This is handled by IP tables, just for implementation details. And then proxy will, based on the configs pushed by pilot, to perform the routing to service B, since the originally this call is intended to be targeted to service B. Then service B's proxy will receive that request and call Mixer to do the policy check. This includes like rate limit or like quota check, authorization check as well. Basically, you can do anything you want with the pluggable model of Mixer. And then like Mixer has those plugins, and Mixer will get back to proxy about this request. Can this go through or not? And once that is accepted by Mixer, then the server-side proxy will forward the actual request to service B. Then service B will here, like, of course, will respond with your business logic is there. It will return the response that goes to proxy B, and then proxy B will send back to proxy A, and proxy A will send back to service A. That is a complete call. And asynchronously to this, a server-side proxy and client-side proxy will both report the metrics to Mixer. So you get the metrics from both sides. One is your server side, how many requests you get, like how large the response is, and another one is the client side, like how long is the total latency. Well, they are like same feature set, but from different perspective. So here is the Istio tracks. The main four is like we have the extensible traffic management, observability, and security. So here is what we got in Istio 1.0. 1.0 means you can use this in production, but we also have different features stages. That is, some of them are in stable stage, some is in beta, some is in alpha. You can consult the official website for this to see what is ready to use. So mostly like the protocols like HTTP1 and HTTP2 is already stable. We're adding more protocol support. We're adding like TLS, oh, that's in the next slide. Like install, core, Helm, those are here. So this is observability, like we do logging to local to mixer, stats integration, stack driver integration. Tracing is also a big, I think there's another talk to cover that. And the security, which I'm going to do demo later. So I'm going to cover three big new features in Istio 1.0. One is the permissive TLS, which I'm going to do demo, so I will skip here in this slide. And another is the gRPC adapter model for Mixer. So basically this will allow you to write Mixer plugins outside of the Mixer process. That means you don't have to build your own Mixer to do your policy check. And also authorization policy is a new one. I will do the demo for this as well. The strong identity bind to service will give you better control to who can access what, and that is very powerful tool. So here we are after like more than 1 year's work. We have about 200 developers from Google, IBM, and VMware, Cisco, pretty much big companies, and we have adapter for many components, like not only security, like stack driver, open policy agent, etc. And also have the API management from IPG. So from here, I will focus on security. So how does Istio enable you to secure every service? Istio does have three simple concepts here. One is enabled you to do mutual TLS to authentication and encryption. It allows you to do without any change to your application code. Second, it allows you to authorize access based on the service identity or also any channel attribute. So it still enables you to create policy that allow you to define who can talk to whom, and then monitor those policies centrally. Lastly, if you are using modern RPC protocols like REST over HTTP or gRPC, then you can configure fine-grained RPC level access controls, and we'll talk a bit more about that. Those are really like the access controls provides rich capabilities that we also leverage at Google. So what do we support Istio, mutual TLS in Istio? Well, it's policy-driven encryption in transit, and as I said earlier, with no application change. So that is pretty powerful paradigm because it's very complicated to manage good TLS stack, write good TLS code, and secure your keys and manage your certificates. That's a lot of work to do there. So itself is a great value, but not the obvious one. So one of the key principles is enabled through mutual TLS is strong authentication. This is something that not so obvious but very critical of the security posture that we enabled. So the authentication model we enable via Istio that peers are always authenticated using non-replayable tokens, non-replayable service identities. And we make those identities non-replayable by binding them through the TLS channel. So this is bound to channels. those identities cannot be replayed by the recipient or anybody who is trying to sniff on the wire, since you don't know the private key. And the data is actually encrypted by POS. A very critical piece here to also understand is this service-to-service identity doesn't have to be your application layer identity. For example, if you have a database and you have the credentials to access the database, it doesn't mean that the service you're running is allowed to talk to the database service itself. The application layer's credential can use to be, for example, if you have a database, you can do fine-grained control based on that, what table you can access, what table you can write, but that is a different layer credential from what service can talk to what service. So, going back to the slide, I talked about the permissive mode. So why do we need this? Is like we realize that not especially in a huge deployment of Istio, you cannot enable mutual TLS in day one for all the services you have already deployed. Your service will have many clients, and sometimes you don't even know how many clients you have, and if you're enforcing mutual TLS in day one, you'll break some of the service without previous knowledge. So, for example, you can start with a service that holds your most sensitive data, and then take most critical client part to enable the mutual TLS. And then, for example, some health checker service or some other client doesn't access to the sensitive data, you don't have to enable that on day one, and you can gradually move your client to mutual TLS. And that will be very powerful, and that is a very new feature, and I will show you later. Okay, go back to the identity. Once we have a strong authenticated service identity, we can use that for authorization. Note that if you don't do the strong authentication, your authorization can be compromised in another layer. So a service has a bit of like dual identity. One is bound to the API or RPC level, which can be like the attribute there could be a URI and JOT tokens and access token or cookie, or if it's a browser. And at the service layer, that could be a service identity like Kubernetes namespace, IP address. Those are the attributes you're considering. You can use the service level authorization policy like Istio's policy to do what both you could do with the traditional firewalls, like based on the IP address and namespace. And you can also bound that to the API level credentials like JOT claims, and you can even combine them. This will give you a more powerful mechanism to do that. So let's take a concrete example to understand this. So here is the diagram. We have a person called Joe here. So you can think he's a support engineer or support engineer who have the access to the PII, which served by the PII service there. But in your organization policy, you could only access the case data through the case tool. The case tool enforces many more organization-based policy, like he can only access the case which is assigned to him, and he can only access the data related to that case. and he may need to keep a note why he did need to access that. So one day, if Joe thinks he wants to invent another tool to access the PII data from his own tool to get more information, this should not be allowed. This will be a potential data breach. So here, in the spec, in the left side, we specify the property that the request also have the claim of the specific user, and also we specify what service can access the PII data here. So if you, in some traditional system before this, you combine this, access through another tool seems like you get requests from someone have actual request to, so it seems like a legit access from just from another path. So this can be prevented by using the strong authentication. And lastly, as I mentioned, you need to monitor your posture. Once you have implementing policies at very large scale, the monitoring is a critical piece, and you need to have a consistent visibility of the security posture. Yeah, so every things that I described here, you can implement in your own business logic. The reason to do that in Istio is you get automatically from the infrastructure, and your developers can focus on what the real application logic. So here is a demo agenda. But before I go to actual demo, does any one of you have any questions? Since after demo, probably I will forget some. Okay, so you're good. So here, the demo agenda here is I will show you the policy-based mutual TLS authentication and how that works, and also identity-based authentication and user identity verification. And through all the process, I will show you the monitoring. So here, the system I'm using today is a two-tier example. This is really, I think you might already see this a couple times of looking for in many presentations. So this might be boring. I will try to make this more exciting. So here, the first we deployed Istio. So I prepared a deployed one here, and I can show you. So yeah, so we got the bookstore here. Okay, so I will show you the monitoring data here. So I have another service that is actually continuously issue requests to this page. So here is the Grafana database dashboard. Hopefully it shows well. So yes, it gets requests. It has the this is a product page, so you get the traffic here, and you get the live. So this is live. Okay, here, this one is currently, as I said, here, no traffic encryption, no access control, no visibility. And I deployed Istio, so we got a little bit more visibility here. So first of all, since this is a regular HTTP site, so I will enable TLS to my deployment. So hopefully the policy propagation takes a couple seconds. So yeah, it already secured. So I will show you a little bit of this. What I did is, so it's basically a policy that set port 443 and set a simple TLS with the certificate I previously uploaded to the Kubernetes config map. Okay. So, okay, I deployed the service. So everyone, please use your smartphone to access this website and hit. We will monitor your access to the in Grafana dashboard. Let's see how many requests I can get. You can try keep refreshing on this website and see. I want to see how much the spike I will get in Grafana dashboard. Hopefully you guys won't crash the service. Oh, cool. Keep refreshing. Oh, nice. We see the live, and you got more and more requests. Okay, keep doing that. So then, okay, hope it goes well. So this thread here, since we already deployed the TLS to the outside access, the thread here is really the insider can access the backend. So what backend does, what backend return here, if you see here, you see the bookstore, this order is the information, like it has my name, has my address, has my credit card number, and know what I ordered. So let me show you how to. So here, I have another pod that runs a. In the insider one, and I also have one in legacy. So here, if you try to curl to get the details from the legacy one, it can see the details. So you see, you get the details, the JSON returned from the backend in the two-tier example. So here you can, this guy is really accessing here and get the successful response from the service. So we can enforce the mutual TLS here. So I will show you here the one before. This is the policy that specifies that the mutual TLS most strict means non-TLS client cannot talk to the service, and the destination rule is for the front end to talk to the details knows that one is enforced by Istio mutual TLS. You guys are not accessing anymore? It's fine. So I have my service in the backend here. So now, and go to the details dashboard. Go to the service of the detail dashboard. So here, I'll scroll down. You see there's a different color here. Here is the writing of the mutual TLS encrypted traffic. And here is the plain text before that. And also, I will try to run the same command that wasn't, you couldn't do this anymore. And you see this one, the connection reset by peer, since this sidecar doesn't have mutual TLS enabled. It's a legacy client. So what's the problem here? So I will give you, I will show you another dashboard which from the product page. So here, you will see you see a spike here that the successful rate drops. That's because I immediately enabled the strict policy of mutual TLS. That means since each sidecar is not pretty consistent getting the policy at the same time, that means if your backend service gets the mutual TLS policy first, it will reject a couple requests before your calling side, like product page, get the policy. So the permissive mode will really allow you to do this without this drop. I think I don't have much time left, so I will probably skip to do that again. So if you're interested, I can show you later. So other thing, the another threat model I described in another one is someone developed another tool, try to access the PII. Remember the joke? So here, even I enabled the mutual TLS, the legacy client cannot access because they don't have because they don't have the mutual TLS. But the insider who can deploy, which in Istio enabled namespace, have their identity there. That's nothing wrong. So. So here I run this in the namespace of insider. So you see, you get the JSON successful response. Since this insider have the sidecar attached to it, the really the ready 2 of 2 means there's a sidecar there. So how to prevent this? So we're here to enable the Istio RBAC. I will show you what the policy bind looks like. Here is the builderscon demo. The policy. Right. So here is the one. So this one, the product page viewer in the namespace default have the access to is the service that product page. And you bind that product page viewer to any user. So basically any user can query, so any service can query product page. And here is the service route for the details that I showed in backend in the curl command return the JSON. We don't want any other tools than product page service itself to access that service. So here we specify this service and the method is get and head, so that this is a very viewer. And we specify the user here is namespace in default and the namespace of the book info product page. And also you need to do is you need to specify the service account for your deployment. So that is in another book info service account. Really, it's create the Kubernetes service account and bind it to the pod spec here. It's nothing special. So let's add the service account first. Then auth policy, apply the auth policy. Then enable the RBAC. So here, I think I forgot to show you this file. This file is in the examples, which basically how much request context you want to extract from each request, like the source labels that in Kubernetes, and the request path, request method, which properties, and here this is the RBAC handler, which is pretty template. So okay. I can still access. Okay, I can access this. So make sure the RBAC doesn't break your application, which is the intended way to access the application. And so you got the RBAC permission denied. And you see you get HTTP 403 forbidden, which is. So we rejected the insider access. So this is the stage right now we are. And here I will also show you how to do the end user authentication. That is a critical part to enforce only the logged in user have the access to the sensitive data. So here, okay. So JOT authentication policy is the policy that we have the spec that the important part here is also the mutual TLS have to be strict, since JOT is a replayable token that you don't want to leak. So if anyone have the access to your network, the token leaked from there can be actually replayed, can be used for the replay attack. So we specify what the issuer, this is my local service account, and we do the policy binding to use origin. So let's wait a couple minutes to get this propagated to the proxies. Are any one of you still accessing the page? No? Do you see any changes? Do you still see the same thing as you saw before? So it says the origin authentication failed, which is because I enabled JOT authentication. So, so how can I access this? I specify the JOT token parameters. So let's check. So I give the token to the request parameter, and you can now access as you could before. So here I also show the end user authentication can be performed by Istio. I didn't change, I didn't redeploy my application, but now these things are all enforced. And that's pretty much all of my demo. Thank you for listening, and thank you for attending this session.
リザンさん、ありがとうございます。
QA タイムに入らせていただきます。質問のある方、挙手をお願いします。
I don't know if this is the right question. Kubernetes network control. Calico can be used to control the propagation compared to that. If there are any pros or cons of using Istio.
So I think the Calico and the Istio is really different layers. The Calico's network policies is the L3 layer, I think. It's L3, or it doesn't do the TLS authentication, so it is only on the IP layer and networking layer. You can use both of them if you really want. They will protect your services from different layers.
ありがとう。
他に質問のある方、挙手お願いします。大丈夫ですか？はい。はい、では少し早いのですが、ちょうど質問がありましたら、後ほどスピーカーの方に直接お聞きください。それではリザンさん、ありがとうございました。